Hello again. Although I am certifying in both mathematics and science and have read both readings, I will focus on mathematics for the sake of my friend Josh. Also, rather than just regurgitate the stages, I'm going to go through them with illustrations of what is involved in the world of mathematics during each of those stages. Stage 0 is getting ready for school. The focus here is on the preschool years at home and perhaps preschool depending on the family circumstances. During this time, children learn the basic concepts, the symbols required for reading with letters and numbers. Also, there is the introduction to basic shapes and groupings. The learning is evidenced as children learn to speak, read, and recognize patterns from parents and teachers. A great illustration that has helped our family during those precious preschool years at home was to read to our children every night from the scriptures. There were big words, and funny sounding words, and stories. We found that as we could go around the room to take turns, the little ones first are excited to bring the scriptures to mom or dad. Then we would help them follow along with our fingers. Then they would want to turn by repeating what mom or dad would say into their ears. Soon they were reading the verses and asking questions. This was supplemented with a favorite read from Winnie the Pooh or children's stories like Dr. Seuss's Hop on Pop right before bed. You know they are learning when they will not allow you to skip even one line, and they want to hear about Digimole one more time. Stage 1 is formal schooling. Reading takes priority with the alphabet, numbers up to 100, phonemics and phonics. By the time a student has reached the 4th or 5th grade, they should be able to read easily from grade level books. In math, they should have the foundation blocks down pat with addition, subtraction, multiplication, and division. They should also understand the fundamentals of basic geometry and some understanding of mathematical vocabulary such as parallel versus intersecting, and an introduction to those all-important prefixes which translate as to how many sides a polygon might have. A critical achievement is the ability to dissect a word problem and solve it. Stage 2 is fluency. Here, after establishing the foundation in stage 1, we introduce the essential subject of algebra, followed by geometry. Equations and proofs are indeed a new set of vocabulary for the student to conquer and to be able to apply. The one or two line word problems become paragraph story problems. Timing becomes critical during tests. Stage 3 is reading for learning the new. Here we begin to combine the algebra and the geometry we have learned and apply it to the field of trigonometry or pre-calculus. The student is required to think more critically as they dive deeper into a more complex compilation of symbols and derivations. However, here is the foundation for college and beyond. New knowledge is gained as application is explored and questions give rise to further investigation. How does one know the height of that building without an infinite ruler? Stage 4 is learning from multiple points of view. Welcome to calculus and discrete mathematics. We leave the two-dimensional world of pencil and paper and enter the multivariable, multi-dimensional world of reality. Here is where math fully integrates with our world and helps us to better understand it. We see application in our real-world businesses and in our technology we see and use every day. This prepares us for the final stage. Stage 5 is constructing and reconstructing meaning, or passing judgment independently. This is found in college courses beyond calculus, which focus on pure mathematical theory. Numerical analysis and statistics allow us to explore phenomena that are just not easily described. Models are constructed in order to predict what will happen as one goes from theory to bench scale and on to full scale operations. If we synthesize the information we have obtained correctly, make correlations, and then prove those correlations correct, we are able to solve real life problems like building a nuclear reactor without a mock up and have it work as predicted, safely and reliably. Overall, literacy is found in the ability to understand problems, analyzing data, and synthesizing information to find solutions to real life scenarios. The key to literacy is recoding for you in your own language. It has to make sense to you. You can start with rote memorization of 2 plus 2 equals 4, but when you can prove it over and over as you grabbed 2 apples and added 2 more and recounted them to get 4, it made sense to you. The key to increased literacy is teaching students how to recognize a problem, translate it into their own reference frame, and evaluate for reasonable solutions. I particularly agree with the text that calculators and computers need to be seen as the tools they are and not an end in themselves. Otherwise, we will lose the drive to continue to improve life as we know it. We will just continue to put a new face on an old story. Somewhere along the way, people will lose interest and the problem will get worse. What we need is to show direct application and encourage out-of-the-box thinking to get us out of this downward spiral. We need to listen to the children and find out what makes them tick today. It might surprise you that a classical song, a classical read, and an original set of Legos still work to inspire greater things today.